In this lesson, we're coming up with a general equation for the path of a projectile. Now, we'll still need to do all of the same things that we did in our first lesson on projectile motion, so you'll still need to find all of those 6 equations of motion every time. The difference is that on the way to your solutions, you'll put your equation for x and your equation for y, which were both in terms of t, you'll put those together, basically by solving parametric equations, so that you have one equation, y equals, and it will be in terms of x and in terms of alpha. Now, don't memorize this equation. Even if it's the same every time you use it, memorizing it will not get you the marks, because you'll generally be expected to do this in the HSC by actually showing all of your working and making the equation. It might actually be a show that question. So unless it's actually provided in the question, don't just write it down. Now, here's how you do it. You'll derive all 6 equations of motion in both directions. Now, best practice is to actually integrate, show your constant of integration, and then show what that constant is. Then you'll need to rearrange x to get t as the subject and sub that into y. You can also use this Pythagorean identity if you want to rearrange your general equation to put it into an alternate form. And then, of course, if you've got a formula for the path of the projectile where y is equal to some formula that's got x's in it, then dy dx will actually be the gradient of that path. And so that can show you the angle of inclination of your object at any moment. You'll use this formula to rearrange it, because once you've found the gradient, once you have your dy dx, you know that the gradient of a line is just the rise over the run, but also the tan of theta is the opposite over the adjacent sides. And those are the exact same 2 sides of a triangle. So these are interchangeable. So now let's have a go at doing it. We've got our initial condition for the velocity over here. We've seen this before. We always start with x double dot, which is equal to 0. We integrate that by finding a constant, and then we say that when t equals 0, x dot is equal to v cos alpha, therefore c1 is equal to v cos alpha. And that helps us get this, v cos alpha. Then we integrate that and we say we get v cos alpha, and if we want to put the t in after the v, we can. Just make sure it's not cos alpha t. I tend to write it with brackets and t, but you can write vt cos alpha, whatever you prefer, plus another constant. Let's call this one c2, and we know that when t equals 0, x equals 0, because by definition we have a projectile that's leaving the origin at time 0, so therefore we can say that c2 equals 0, and now we have our formula for x, which is v cos alpha t, or we can put our t in there as we've mentioned. So we have this one, we have this one, and we have this one, and now finding our y double dash is minus g. Let's go in terms of g here. Other times we use minus 10 or minus 9.8. Now we need to integrate that once and get minus gt plus a constant. Let's call it constant 3. And when t equals 0, y dot is equal to v sine alpha. Therefore, c3 equals v sine alpha. So that means that y dot is equal to negative gt plus v sine alpha. Now we need to integrate that again. Whoops, we don't want the dot on it this time. And we get minus g over 2 t squared plus v sine alpha multiplied by t, and we can again put the t in after the v if you want to, plus another constant of integration. And we know that when t equals 0, y equals 0, because by definition we're starting it at the origin, therefore c4 equals 0. So y is equal to negative gt squared on 2 plus v sine alpha t. Again, put the t in here if you'd rather, and that is our formula for y. Whoops, I've cut off an important part of it there. You can see what I'm doing. So we have our 6 formulas like that. Now, for finding the general equation, the 2 important ones are these. We're going to play them off against each other. Now, after you've done this a couple of times, you're going to get good at it and you're going to feel frustrated writing out all of this. but these bits are all necessary to show your understanding of the process. Now, because I'm running out of board space, I think I will rub all of this out and just write the two important bits again at the top. So I've got my formula for x and for y here. I want to start by rearranging this. So I've got t equals, so t is going to be equal to x over v cos alpha. And now I need to sub that into the equation for y. So therefore, y is equal to, now, negative g on 2, I'll write that separately. Then I've got to do t squared, which is all of this squared. So for the moment, let's just put all of our working down like this, so it's really straightforward. Then we have v sine theta, sorry, alpha we're using, multiplied by t. So now we need to multiply that by x over v cos alpha. Now we just need to tidy it up. And now we need to be careful with our fraction here that we're squaring the top and the bottom. So we're going to have y equals negative g x squared on the top, and on the bottom we've got 2v squared, and then we've got cos squared alpha. Now, can you see an easier way or a simpler way to write that? Instead of cos squared alpha being on the bottom of the fraction, we could actually say that this is sec squared alpha. So we're going to change that and put sec squared alpha actually up the top. Now you can make that fraction line come all the way along, or you can just have a fraction sitting out the front of the other term. Either way is fine. And over here we've got our v's are going to cancel, and sine alpha over cos alpha is just tan alpha. So we get x tan alpha. Now, can you see that this one is better than having cos squared alpha on the bottom, because sec squared alpha and tan alpha are actually related. They're related with the Pythagorean identity. So if you want to jot this one down on the side, this is the one that's on your formula sheet, but if you divide all three terms by cos squared alpha, then you get this one. So this is a perfectly good formula, and you can use it like this. You could even use it with the cos squared alpha down below, but you can also rearrange it and say that we've got minus g x squared over 2v squared multiplied by tan squared alpha plus 1 plus x tan alpha. And by doing that, you're making life a little bit easier when you come to solve it for alpha, because both of your alphas are in terms of tan alpha. So those are the two forms. Now, don't memorize either one of these. Sure, be familiar with them and know that they exist. If you get one of these in a question, you can go ahead and just sub things in. But if you're asked to generate this, don't just write it down from memory. You need your 6 equations, and then you need to rearrange x in terms of t, sub it into y, and tidy it up, and potentially tidy it up again.